Hello, everyone, and welcome to Pulumi Up. Thank you so much for joining us today. My name is Kelly Fitzpatrick. I am a senior analyst at RedMonk, which is a developer-focused industry analyst firm. And I am delighted to have the honor of moderating this industry panel on infrastructure as code. Now, if you are at Pulumi Up, chances are that you already know about infrastructure as code, but for those of you who are new to the term and maybe just dropped into Pulumi Up at this session, infrastructure as code is the management of IT infrastructure, such as containers, VMs, network configuration through code, which allows for affordances such as versioning. We have an excellent group of experts with us today to talk about infrastructure as code, and we are going to kick things off with a round of introductions. So we'll kind of go around to each of our panelists. I'll ask them to introduce themselves, to talk a little bit about what infrastructure means to them and what motivates them to kind of do what they do every day. And Paul, we'll start with you.
Hi, I'm Paul. I'm a Java architect at the Java Platform Group in Oracle. I'm actually really happy to be here. It's really interesting technology. And I mostly work on designing the Java language, the libraries, and the compilers. So I am right deep down in the stack and not above. But in prior lives, I worked at CloudBees in its early startup days where infrastructure as code didn't really exist. And we were flying by the seat of our pants, deploying stuff as we went. And then I had an opportunity to work at Netflix where it got far more sophisticated in terms of deployment, where developers would build tools for developers for productivity. And I think that's really interesting with regards to infrastructure at code here. It's a real big developer play. What motivates me is the ability to do something that has broad impact for developers. Java is used by many, many developers. Even the smallest feature can have the impact on a developer's life and make them more productive. So that's what really gets me going.
Yeah, I like that we're starting with something that developers may have heard of, like Java, right? Nova, let's move on to you.
Hello, my name is Chris Nova. I am a senior principal engineer and architect at Twilio. I'm our lead architect for our infrastructure platform, and we're building everything on Kubernetes. What infrastructure means to me, I look at infrastructure as the sort of unfortunate or unnecessary tools and services that need to be supported and sustained in order to enable commerce. Metaphorical to a bridge. It exists, and it exists so that folks can do arbitrary commerce. And in a perfect world, it wouldn't necessarily have to be something we would have to build or design. It solves a very easy problem in a very complicated way. What motivates me is, I think, just that. It's complicated. It's hard, right? Infrastructure is engineering on expert mode. Not only do we have to solve all the problems of an engineering team, but we have to do it on a budget and with a lot of complexity, as we're typically solving for more than one use case at the same time. So the complexity and the constraints is really why I'm here.
I think complexity is definitely a term that I feel like we are going to get back to at some point later in this conversation. Kat, on to you.
Yeah, thanks, Kelly. So I am a newly minted developer advocate at Kong, primarily focused in support and consulting prior to this in all things infrastructure. So hopefully this conversation is going to be fun to dive into my experiences and my customers' experiences there. I am experienced at Dell, Canonical, Red Hat, and Kong before. Sorry, I should know how to introduce myself. Yeah, I experienced at Dell, Canonical, Red Hat, and Kong. And what is infrastructure to me? So all things from the boot sequence of the hardware to the layers that we put on top of that for infrastructure, virtualization, containerization, but also the networking and all of the pieces that lead to doing useful work, like Nova said, with all of the hardware that we have in compute today. What motivates me? So I like to see people more successful today and tomorrow than they were yesterday. Finding that easiest path to a reliable and sustainable success is that piece of the puzzle that I like to solve.
I love that. And I know that you've only recently switched into your current role, but I feel like that's a good role for you based on what brings you here every day. And then last but not least, Elad.
Hi, everybody. Super excited to be here. Thanks for having me. I'm Elad. I'm the founder and CEO of Monada, which is a brand new company, actually just was created this month. I've been at Amazon before that, left around February for about 7 years. And I've built the AWS CDK at Amazon, CDK for Kubernetes, JSII, Progen. So kind of started the CDK programming model, which was based on an internal tool that we've been building at Amazon.com. I'm still trying to figure out exactly what Monada is going to do. I think to me, and going back to like what motivates me is the the beauty and the power of software and its incredible ability to create things, imaginary things that can change the world. And so my obsession has always been, since I was like 10 years old or so, around developer technology, developer experience, making that experience easy, fast, and enabling software to become, more and more powerful and more enabling for our lives. About infrastructure, I think like that's a really interesting question, actually. Like, what is infrastructure to me? Because I feel like infrastructure has been kind of tainted in with the cloud. I feel this terminology of infrastructure is something that we borrowed from the days of data centers and networking devices and cables and power. And slowly this term moved up the layers of our applications. And today, to me, infrastructure is not just those lower, level capabilities, but also resources that enable application development and commerce and business creation. And I think like that's one of the challenges that we're seeing with the cloud today is this real confusion in a sense of the industries. Like, what is infrastructure really? Like, what are the boundaries? And I think we're probably going to talk about that later.
Yeah, oh, thank you all of you for being here today. Those were great introductions. Just so I don't come across as like cheating and skipping the hard part, I will say that infrastructure for me is something that I never want to have to deal with. So I'm the third people who are out there dealing with it for me, so I mostly don't have to deal with it. And I do what I do every day. I'm an analyst. I have a slightly different kind of job description than most of y'all, because I get to talk to people like yourselves like every day, which is like a great motivating factor for me. So moving on to some actual questions. If you caught today's keynote, you know that Pumi has a number of announcements around kind of different like new features, such as support for Java and YAML, the kind of multi-language AWSX packages, and some announcements around the AWS CDK or Cloud Development Kit. So let's kind of start off talking about kind of technologies, stacks, and frameworks that, in your mind need to be supported in order for an infrastructure as code setup or platform to meet the needs of today's organizations. And this can be anything from specific languages to technologies such as containers to whatever kind of falls into your kind of definition of technology stacks and frameworks. And I think, Paul, we will start off this question with you.
Okay, thanks, Kelly. I'd just like to say that when you said you didn't want to deal with infrastructure, that really resonated with in prior lives. Dealing with infrastructure was extremely painful and stressful, especially when you're held to the wire, having to support customers and so forth like that. It really creates pressure on you. And I think one way to improve that is to leverage language platforms to develop code that deploys effectively a computer with a storage network compute to build your applications on top of. And I think language platforms are important to that. And obviously I'm biased since I work on Java, and Java has a huge enterprise footprint. So providing APIs in Java to do infrastructure as code, I think is hugely important and will create a huge sort of pull for Java developers to build infrastructure as code. So if I want to deal with infrastructure, I want to deal with it in code in Java and using a language that I'm totally familiar with, using all the tools that I'm familiar with, debugging and so forth like that, all the IDEs and all the nice language constructs. I do not want to write a YAML file, please. I've had enough experience with build tools, with XML and Maven, and I do not want to write that. I want to write my Java code to do these things. And so that is really intriguing and interesting to do that. And also putting my language hat on, I'd be interested to know what challenges are introduced by infrastructure as code on the language so we can improve the language and libraries and platform to make that even better.
I love that, the idea of languages themselves evolving, because they do, they have to, or they die, in order to meet the needs of what we're now kind of using before. I think that's great. Elad, your thoughts on this?
So I'm 100% agree about the languages. I think the complexity, we've seen like incredible growth in complexity of, the amount of infrastructure resources, for lack of a better term, infrastructure resources the applications are using in order to build, cloud applications. AWS has been a really interesting experience because in a sense, you kind of like live in the future in a way, about especially when it comes to like cloud adoption and heavy use of cloud resources, and normal services at AWS use 400 resources easy, and those applications are deployed across multiple regions and accounts, and so this complexity is something that, in my experience, only programming languages can manage, and this is basically what we've been building with programming languages in the past 50 years, is like managing complexity through composition and abstraction and API design and surface area and modules and libraries and testing, and so I totally agree about languages. Obviously CDK is like comes from that philosophy, and Pulumi is coming from that philosophy, so +1 in languages.
I'm like sensing a trend here. Although I have to say, like the announcement of like support for Java and YAML, like those are almost like very different.
Indeed.
Different audiences that you're kind of aiming for there. Kat, how about your thoughts on what technologies or stacks or languages do you think are important?
Yeah, so if I'm looking at accomplishing a goal for my organization or for myself, and I want to make that a repeatable success or a sustainable success, being able to see the tools and understand them is important, but having an interface to express the entire picture is important. So in my infrastructure days, hands-on metal, I spent a lot of time running commands over and over and over again, and over time, slightly improving my sophistication with being able to achieve that success again or share that success with someone else. But my motivation for learning programming languages, so to Paul's and Elad's point, I am new to programming languages, and my motivation for that is because all of these, even declarative models of achieving an outcome, have individual constraints limiting my options for dynamic and intelligent success. So getting into the new programmable IAC has really glued together all of these different automation patterns and enabled me to hand things to my customers that gives them an intelligent outcome instead of just one very static outcome. So I see it touching anything that you need for a successful outcome for your organization.
And I love your focus on this is what I need in order to give my customers, because I think that that's a perspective not every developer has, many do, and all maybe should. Nova, what are your thoughts on major technologies, stacks, or languages that you think are important?
I'm going to have a good answer. I'm also going to have a difficult answer. One of my biggest criticisms as an architect is my inability to be prescriptive and offer a very specific, concrete answer to a question. When I look at what major technology stacks and frameworks and languages should we use, to be honest, I don't care. What I care about is responsibilities. I want to know what the responsibility of a specific org or a team or a specific use case at a corporation is trying to solve. And then I let that responsibility and their need to adhere to that answer the question, right? Like, really doesn't really matter if we're using Go or if we're using Rust or we're using Java, right? You know, at the end of the day, it all goes to a system call. So it's like, it's really just a flavor of like, what are your people more comfortable with? And if you have 100 Java developers, I'm not going to tell you to go run Go and vice versa. So really, like, the first question I like to ask is, more importantly, who's doing what? Who's responsible for what? Who's responsible for building the platform? Who's responsible for operating the platform? Those are two different jobs, right? The folks that build your car that you have parked in the driveway are not the same folks that drive your car every day, right? So having a clear understanding of who actually is responsible for doing what is really what's going to inform my answer here. We like to talk about Kubernetes. We like to talk about, cloud technologies and infrastructure as code and infrastructure as software. And, when does static YAML stop and when does like Turing complete programming language start? And like, it doesn't really matter. What matters is that you're picking a tool that's appropriate for whatever problem you're trying to solve. So I don't know, it's a good answer because like, I really mean it. And I have built an entire career on being able to answer that question well, depending on the circumstance. But like, I don't think there's like one single pill that we can just give people here that's going to solve all their problems. Like, I think, in fact, really what I would like to see is better guidance on how to come up with the answer based off of your situation.
Yeah, and that is an excellent answer. I love the car metaphor, and I'm thinking like the people who built the car are not the people who maintain the car either, much less me, who like I barely can drive the car, right? So I think there's that metaphor can go like a whole bunch of different ways. And I think one thing you really get to as well is one thing we've definitely seen in the industry, or that I hear a lot, is people trying to find people who are skilled in doing different types of things. So like your point about like, if you have Java developers, you're not going to be like, we must go use Go now. Like there are certain kind of constraints and ways that kind of teams already are that need to be taken into account when you're looking at like what they should do next and how they should do certain things and adopt certain technology. So that's a great answer actually from everyone. And I think that's a really good segue to the next question that I have, because what has become apparent to me just like talking with you all for just these few minutes is that we all come from like very different kind of backgrounds and are currently working on different types of teams and at different types of companies. So I was hoping that you all can talk a little bit about what your team or your organization is like, and then how infrastructure fits into how like your team's like existing developer workflows kind of go. And I think Elad will start with you on this one.
Okay, so it's a really interesting question, I think, because coming from Amazon, I think Amazon is kind of like at the extreme end of that spectrum. It's like every engineer at Amazon owns the entire stack. They know what a VPC is. They know what IAM roles are. They know how a fleet is deployed. They know how VPC connections work. And then they know all the resources above and eventually the business logic and the application. And they also operate the application and become on call. So there's basically no separation of disciplines and across the entire company, enterprise retail business and AWS. And that's a really interesting, engineering culture that exists at Amazon. And since I've left Amazon, I've actually had, dozens of conversations with other companies, because I was like, I probably have like 80% of my view is blind spots at this point. So I need to talk to people. And I've seen that there's such an incredible range of organizational styles, especially around infrastructure and DevOps. And some companies have centralized platforms teams that basically build the entire platform and then give other teams, application developers ability to build, put their applications on those platforms. Some companies would sprinkle DevOps people across the entire company. Every team has their own DevOps person, and that's becoming like their speciality. Some teams use a vertical platform that's a third party, and then they just give their developers the ability. So it's a really interesting question in the sense that I don't think that there's like a majority vote here. Like there's all the range of options, and I think like there's pros and cons to all of them. The thing that strikes me really strongly, especially leaving Amazon in that sense, is that I do think that that we have two distinct disciplines when we're building software. We have engineers and we have developers. And not all developers are necessarily engineers. If you go to a bank, there's amazing developers there that are building tax calculation systems that are really not engineers. They're not interested in like how that network works, right? Like their domain is tax calculation. And I think not respecting these two disciplines when we're building organizations, technical cultures, is a problem because it's not efficient, right? Like we're trying to shove these two engineers into the same person. So I think Amazon's choice is interesting. It works really well in a sense. So I'm trying to understand exactly what works and what doesn't. But yeah, that's my observation so far.
I feel like we could have the rest of the session talking about like the difference between what we say developers and engineers, and oh my goodness, that I feel like that has to be an entire other conversation that we have another time. But nobody.
Maybe that's not the right term. Like I'm trying to even find the terms for that. Like maybe it's the application developers and like ops people, IT people, ops. I don't know. Like I think like we don't even have the right terminology for that.
Yeah, and the tech industry is not very good about sticking with the same terminology either. So we use words in very, very interesting ways. One dichotomy I have heard of recent is like application developers versus say platform developers, which sometimes stands in for kind of platform engineering or platform engineers. So, I mean, there's that. But more on your team and how developers kind of deal with infrastructure in it. Kat, what is happening at Kong?
So again, representing like support and consulting organizations where we plug into literally wherever a customer is at. I honestly think I would have answered this question different a year ago than I would today. So when I was exclusively at the infrastructure layer, and that being your platform, whether it's virtualization or containerization, but really what your app is running on top of, and just building those pieces. I saw it very black and white in a scenario that ops is building a platform and throwing it over the wall to the application developers. And then the application developers are throwing very sometimes obscure requirements over the wall so that ops can develop that feature or develop a new platform that meets that need. And more recently, I've been spending more time in the middleware and seeing the actual convergence of the operations teams and the developers and where they bridge those gaps to create a useful product. And that's really changed how I view, it might be an overused term, but GitOps. So in contrasting customers that achieve success at a high velocity versus more traditional customers that I've worked with, you have a difference of everything is a meeting, or you have everything is a get action, whether that's opening a bug or an issue for an enhancement or what have you. In one paradigm, you have calendars to address. In another paradigm, you're working in a declarative way that is describing what you have today and what you want tomorrow in a language that from what I've seen, most ops and developer teams can find a way to mutually understand and communicate efficiently through. So where does infrastructure fit into my organization is less relevant, I think, for my answer than where does infrastructure achieve success and how for my customers. So I think that's the question that I really tried answering more there.
No, good answer. And again, the kind of focus on the success of your customers, I very much appreciate that. And Nova, you had been saying like, in the green room that your understanding of even the term organization is like very different than most people think of it. I mean, because you're at Twilio, which uses it in certain ways. So, you know, what are your thoughts on this, on teams, organizations, and where infrastructure fits in?
Yeah, speaking to everyone watching who has or currently works at Twilio, I'm sorry we use words in special ways. I'm working on it. I'm doing the best I can. But really, what I was alluding to with what I said earlier was, I think when I look at a corporation, a company, a tech company, like you know, let's say the size of Twilio, or you know, another company that has profit-focused applications that they support. Like Amazon is a good extreme example because they're so big and they're very focused on infrastructure. But you know, Microsoft or Salesforce or Oracle or Cisco, like everybody's got products. You know, we all have things that attempt to make profit, and that is like one kind of unifying thing that we can agree on in our economies of Silicon Valley here. Infrastructure breaks that mold, just like full stop. Infrastructure is a cost center. Infrastructure is a liability. Like we are a necessary evil that in a perfect world would not exist. And like I've kind of made my peace with this like ugly truth. And when I look at organizational structure, I think that infrastructure typically reflects that. Like it's very obvious, especially at these larger companies, that infrastructure is the small, it's like organizational center that is the core of the rest of all these like very exciting profit centers that surround it. And right down in the middle is like, how do we manage our infrastructure at scale? So a lot of the tools and technologies are a reflection of this macro shape, right? Like how do we do things generically so that this profit center and that profit center can like take advantage of the same pieces of technology here. So when I say org, really what I look at is like each org is a use case as far as infrastructure is concerned. I also look at the sort of like interesting economic relationship between everything is like profit center's job is to go make profit and infrastructure's job is to reduce cost, right? So like we pay for ourselves in different ways and like there's different paradigms because of that and because of that economic relationship. So when you try to build quality infrastructure for these different consumers of your infrastructure, you know, really the question isn't how do I do it the right way? It's how do I do it in a cost-effective way that's going to work for as many people as possible, right? And that changes the game, right? That's why infrastructure is just fundamentally different than like applications, is because we're just operating under different rules. It's just a different game. Anyway, this is why I get excited. And when I look at organizational structure, I am like, you know, we're kind of on the defensive versus where like our consumers are on the offensive. And I think that my tools, my decisions, my technologies, the type of people we hire, the type of work we do, all of that is a consequence of this macro shape that I see at these larger tech companies.
Yeah, and I love that kind of like, just like very kind of bird's eye view of all of that, as opposed to, you know, getting into the you know, very much kind of specifics. And Paul, what are your thoughts on this?
Just an observation on categorization of developers. I would think that someone who writes Verilog for a CPU probably thinks of me as an application developer. So I'm looking up and also looking down, and I think everyone's looking up and looking down. And there's a whole stack of software that people are depending on each other at various parts, which require various different skills. And one of those is maintaining infrastructure at various levels on the stack, and at the point at which you've effectively got sort of Lego bricks, and you're writing software to connect those Lego bricks into sort of a high level machine. Well, not just one machine with a CPU, but a big machine that's controlled by software and configured, and it may be dynamic. It's not something that's static and grows and shrinks and expands as the requirements of the applications are needed. So it's really the economies of scale. So you can just shut it down and not pay them and build it up as you see fit. And that's like really, I hate to use the word elastic computing, but that's what comes to mind when I think about it. But it is just configurable compute. And we're abstracting away the notions of network, storage, and CPU, and being able to fit them together as needed, GPU, CPU, FPGA perhaps, RDMA networks and so forth like that. So that's where I see it. It's software to enable more software and more machines as you need it. So it's just a sort of progression of the industry. And I think from my point of view, I do a lot of work on my laptop and deep thinking on my laptop. I'm lucky enough to do that. But then I was thinking, well, we have an infrastructure team in the Java platform group who's responsible for making sure the builds work, making sure all the tests, performance tests, unit tests, infrastructure testing, functional testing. And if that thing goes down, we stop because we can't progress. So it's really important. It's kind of the mission critical for us because a lot of engineers aren't working. That's an expense on what we do. So, well, of course, we can do other things, but it stops critical work going forward. Like if we have a security fix coming through, we need to get through. If that's down, then we're blocked. And these people build up a Mesos sort of cluster and enable all this. But it's quite demanding, and the broad array of machines we test on for the platform, all architectures, old and new, and so forth like this. And then I've been working with people who've been deploying on Oracle's compute infrastructure and deploying bare metal machines and want to test Java processes interconnected over InfiniBand or RDMA, and how do they deploy that infrastructure quickly and then tear it down after they've done and deploy it back up again and code that up. It's not easy to do at all, and we got to enable them to do it faster and more accurately and more efficiently, so they can get their job done.
Good answer. And also, as you were talking about when infrastructure is not working, like A, people cannot do their jobs, but B, it's also somebody's job to get it back up and running, and that's having some flashbacks to previous life, I think.
Oh, yes.
Like, absolutely.
Yeah.
So I want to shift gears a little bit and talk about a trend that we are seeing is this kind of increasing introduction of abstraction as a way to reduce toil and to maybe reduce some of the complexity that we're kind of seeing more and more in the building and running software. And I think all of you have talked about this, like, or touched on it a little bit. What are some kind of common abstractions for infrastructure that make your life easier, or if they were to exist because they haven't been invented yet, might make your life easier? And we'll start with Elad.
So yeah, I think it connects a little bit to what we discussed earlier about programming languages and the fact that basically the basic tool for managing complexity in programming languages is decomposition, right? Like, it's taking a problem, breaking it down to smaller pieces, and then combining them together into higher level components, and then combining those together and again and again. And basically, the entire software world is based on that premise. And I think what we've been seeing it with the infrastructure and introduction of infrastructure as code, and then introduction of infrastructure as software, is just a repeat of what happened in the traditional software world, right? Like, hey, we've got all this complexity. Let's use abstraction in order to manage this complexity. One thing that we've been seeing around infrastructure complexity abstractions that's I feel is interesting and is in a sense unsolved problem in a way, is that these abstractions sometimes break when you deploy them into the cloud, right? And so you have these abstractions, whether they're Terraform modules or Pulumi components or CDK constructs, and they all look shiny and nice, and you have these APIs and non-leaky surface areas. But then you go and you deploy them to a cloud provider or to Kubernetes, and suddenly you're left with like the Lego bricks, right? Like you're going into your Lambda console and you see, 20 different Lambda functions, and some of these Lambda functions belong to this component, and some of these Lambda functions belong to these components. And so I think like one of the challenges, or maybe the barriers in the infrastructure as code or software space to kind of like blow up in terms of abstraction, is we have to solve that production problem. Because if we're not going to solve that production problem, we end up in this situation where abstractions leak once we deploy them, and then people who are trying to operate the system don't have a back reference to like, where did this resource come from, right? And so I feel like what we're seeing today in the infrastructure abstraction space is just the first layer, in a sense, of abstractions above the basic resources. And we've, the AWS launched Construct Hub last year, at the end of last year, which is this like website of constructs for sharing infrastructure abstractions, basically, for Kubernetes and for AWS and for Terraform. And as the keynote said, I think like Pulumi is going to be able to support these constructs today. So I think like we've got the foundation for the ecosystem of software-based cloud abstractions, and we're seeing some really interesting stuff there. But I think like it's going to blow up once we're able to really solve that production leakage problem, which I think is an interesting problem to solve.
An interesting way to think about it, as well. Kat, your thoughts on abstractions?
Yeah, so if I'm looking for a tool that abstracts away tasks that make my life harder, I usually start out by seeing how they apply to the most difficult common denominators of any customer that I've worked with. Usually that boils down to fintech and defense organizations, as they have any number of constraints for security, for whether it's disconnected, running in the middle on systems in the middle of the ocean. And if I find a pattern that really enables success in those extreme environments, usually what I also find is that reduces friction for other more common use case, or even more agile and younger organizations. So in the real world, I see the biggest pain points around data distribution for whether that's dependencies, databases, what have you, and either very declaratively and programmatically understanding what you need and traversing the path to get that into your production. So that could almost be improved by programmable data, where the data itself tells you what it is, or declaring methods of version. I'm going to jump into kind of the next piece of that. It feeds back into the data distribution piece. So the other biggest pain point that I see is release orchestration and release update orchestration. So once you've accomplished your first day in prod, you start thinking about, okay, what is my next version of prod going to be? And because the stack is so deep, and each layer of the stack is very broad horizontally. I mean, I think Paul really eloquently explained some of the fact that he has Mesos clusters that are required for releasing a patch to Java if there's a CVE. And so if you look at how deep and wide each layer of the stack gets, version control and maintenance of all of the versions involved in releasing a production application are, I think, some of the most difficult parts of infrastructure and maintaining infrastructure. So being able to very carefully declare all of your dependencies and versions and move all of your dependencies through a software supply chain. Those are the two things that I see as the biggest gaps and most difficult tasks at this time.
Yeah, thank you for that. And I think I really like your idea of, if it can meet or work for these kind of very difficult use cases. Like what can it do for those kind of more everyday ones, like that type of angle as well? Because we don't often think about the most difficult use cases, the edge use cases. We think about, we think about that every day, but you can learn a lot from those edge use cases. Nova, your thoughts on abstractions?
Such a good question. So abstractions are for humans. Full stop. Right. I'll just stop there. As far as I can tell, in the history of computer science, in the history of forever, this is a very simplified view. There's only two reasons you would ever abstract anything. And it's either to decouple two computer systems or to create a better user experience for a human. So there's some like nuance to this when you get into like, okay, well, we have two computer systems that we tried to connect in a human-like way, and we need to decouple these two systems as like a reverse exercise. So abstractions are useful there, but again, the only reason that problem exists in the first place is because we tried to make a computer speak to a human. And I also look at it as, we're presenting a computational layer to a human, and that's where an abstraction also becomes useful. So if we didn't have humans, we wouldn't have abstractions as far as I can tell. I look at the problem with orgs that I kind of talked about earlier with like the macro design of like we have an infrastructure org in the center of all of these profit centers. If you were to use the word domain to describe each one of those responsibilities within a corporation, this is a one profit center that makes money in this way, and here's another one that makes money in that way. Each one of these domains has a unique responsibility, and each one of the domains needs to answer the same questions potentially in different ways, right? And this is like the nature of all Kubernetes and cloud native and all the stuff we talk about every day. Is every domain needs observability. However, this domain needs to solve observability for these specific things, and that one needs to solve it for a different reason. But regardless, we need this problem solved here. This domain needs logging. That domain needs observability. This domain needs networking. Infrastructure tries to glue all that together and find the boundary. So really, I don't really want to talk about abstractions very often in my day job. When we do talk about abstractions, I usually just try to get down to what computer system are you trying to obfuscate? What I really want to talk about is boundaries. Where does this org's responsibility boundary stop, and where does that org's responsibility boundary start? And how much of this shit is are we responsible, and how much of it is responsible on that end? And then I think that's where you get these clean like systems designs, these patterns from, where it's very obvious where Kubernetes starts and stops, and it's very obvious where this HTTP API starts and stops, and what the interface and expectation. That's a big responsibility for an architect, right? Being able to say this is infrastructure, and ultimately you as an app dev team are going to be responsible for security scanning your images, or responsible for configuring your network, or contrary wise, that's my responsibility. You should be obfuscated from it. My suggestion here is to make infrastructure as boring as possible. I would say the big anti-pattern here is we don't want infrastructure to be configurable. We don't want people tweaking config options all day long. We don't want people changing it. It should be a bridge. It should be boring. The same reason that folks don't get in their car and drive up to a bridge and go like tweak the dial on the side of the bridge and say like, I want to drive a little closer to the water today, is the same reason we shouldn't have configurable infrastructure. It should just get you from point A to point B, and you should not talk about it. You shouldn't look at it. It shouldn't be attractive. It shouldn't be beautiful. You don't want to take pictures with it. You should just drive across it and get on with your day.
I never want to be responsible for a bridge. That's like a career goal of mine, to never be in charge of bridges. And Paul, your thoughts on abstraction?
It's such a broad, deep question. I want to expand on what Nova said on abstractions. We have to have abstractions to understand the world, because otherwise it's too complicated to think about. It just doesn't fit in our heads. So we have to create analogies and metaphors. And often we talk in metaphor when we build new abstractions, and that's when new terms come up. And anyone who's outside of that world, it's almost incomprehensible when people are speaking. And you even find that across organizations that are talking about the same things, but have invented the same things and come up with different terms for it. And then you have to sort of merge things together and then collapse those terms to say, oh, we're talking about the same thing. We have that even in our organization. I'm swimming in abstractions every day, and up and down the stack. I'm trying to understand what these are. I think it reflects for the programming language platform as a mechanism to build abstractions by humans. And one abstraction is to try and provide software to deploy infrastructure or manage infrastructure. And I think embedding that into the abstraction building mechanism is actually quite liberating, because you can use all of the same mechanisms that as a developer you can use today. For it, you're building your own abstractions on top of those of infrastructure and build libraries and modules and so forth like this. And things will start going up the stack. If Pulumi have got this right with the right APIs and the right level of abstraction, then it will enable developers to build on top their own mechanisms and be creative in ways that they don't expect. And that's effectively what we do at my job, at my level. We find the sort of the primitives for the feature we want and let others build on top of that. And the important part of that is finding the primitive and providing a story to developers so they can understand what that primitive does.
Paul, I love that you kind of took an abstract, you started with a very abstract view on abstraction and then kind of got into this. That was very fitting. So we are getting to the kind of the end of our time, and I want to jump to a kind of like lightning round question to kind of wrap up. If you were to advise someone who is either early in their career or considering getting into a career in tech as either a developer or an engineer, whichever one of those terms you want to think of, what skills do you think they should know in order to be successful? What should they be studying, or what other advice would you give them? And Kat, we'll start with you.
Thank you. This is one of my favorite topics. My own adventure into tech started out in a library book. I usually visited the STEM section, which was a very limited selection of books in the middle of Oklahoma when I was a kid. And I stumbled on a Rail 3 book, and it had scratched up CDs in the back. And I eventually got those after weekends of trying, working on a discarded computer that my parents had in the garage. That's my own adventure. I can't imagine getting into tech today when it's so much more complex than just getting one system working. So if I do advise someone when they're curious about technology and making a profession out of it, the first thing I ask them is, can they imagine something and then figure out how to make it happen? And it can be really, really simple. So some people are comfortable installing a browser, some people aren't. Those might seem like trivial tasks to a lot of us that are seasoned in tech, but if it comes to, can you make a new MacBook, for example, as comfortable to work on as the one that you've been using for the last 3 years? And if you think about it in terms of, this is foreign to me, so it's scary, then all that it boils down to is, can you teach yourself the bridge building skills to get to the destination that you want? And can you face it without being afraid and without caving into your biases? So if you think that picking one technology because it was promoted by someone you like as being an obvious choice, that's a fun way to get started. But if you want to do things more than one way, just to understand if you're doing things the best way, can you encounter your biases? Maybe I don't like Red Hat, or I don't like Canonical, but can you look and see why and whether or not that's a valid reason for picking a bridge or a type of brick to build that bridge with? So break things down into small pieces. If it's of a foreign idea and it's scary, make it really small and see if you can work and chip away at that one step today, tomorrow, the next few days, however long it takes, and then start building a habit of successfully achieving the vision that you set out with.
I love that. It makes it all seem so much less overwhelming. I'm gonna throw our order to the wind, and Paul, I'm gonna ask you to go next. So I feel like you've had to go last for like the past 5 questions. So what advice do you have for folks who want to get into this business?
I wish you said last so I could think about it more, but I'll go ahead. Oh, this is a curiosity and persistence. I think you have to be curious and you have to challenge yourself, but also you need to be persistent and not give up. And because sometimes it can be hard. This is quite challenging sometimes. And so I think to help that, you have to find the right people you're comfortable with and they're comfortable with you, and go on effectively a journey and find the right people you're comfortable with who can mentor you. I think finding a good mentor is can be quite important, and it may not be something that's explicit. It may not be an explicit mentee relationship, but someone that you can relate to and you can sound out ideas on. And so sometimes it can be you just hit on something by chance that you enjoy and it resonates with you, and if something like that happens and you're lucky enough for that to happen, I would grab hold of it and run with it if given the opportunity. That's my thinking behind it.
And good mentors are hard to find. So when you find a good one, like, try to keep them. Nova, what advice would you have for newbies?
Yeah, I'm going to take this opportunity to plug the new book I just published. I've been super obsessed with this topic for the past 6 to 9 months, and I gotten so obsessed with it, I finally took pen to paper and wrote a lot of this down. My big takeaway here was tech has more to do with the economy than I thought it ever would have, and I wish somebody would have told me this a lot earlier. I would have, if I could go back, the one thing I would yell and scream at my younger self is, Nova, your career, your job, tech is a vehicle to retirement, is a job. And ultimately it exists in an economy, and ultimately that economy, if you're in the United States, is capitalism, which means you are a consequence of a labor market, and a corporation's job is to extrapolate more value out of you than they get in return. And it's kind of slimy and it makes you feel pretty bad. I would have protected myself differently. I would have managed my situation a lot differently. And I would have taken a lot of a different approach to how do I manage my money and how do I manage my relationship with my paycheck. It sounds like a very grown up, hey, save your money kind of answer. But after working at some of the larger fund companies and getting burnt a few times, man, I wish I would have spent 3 or 4 months just researching basic economic principles and understanding where I fit into the big machine before I started this undertaking.
Yeah, I love it. Tech is not in a vacuum, and oh my goodness, it's definitely not in a vacuum when it comes to money.
Right, and this is why I think about infrastructure the way I do, right? We're a liability. Most corporations don't want us to be there, and that changes a lot of how I approach my day job, right? Walking into the office knowing that, it just explains things. It just makes things a lot easier for me to kind of take in stride. So
excellent. And Elad, your thoughts on folks thinking about getting into this industry?
Get involved in open source.
Yeah.
That's it.
Yeah,
I like it.
I think short and sweet.
I
I
like
think
it.
it's the best. Find mentors, build something real, see how you actually work as a developer.
Contribute to documentation.
Contribute in any way you want, open bugs, contribute to documentations, send pull requests, comment on other people's pull requests, connect with the community, meet friends. I think that's a great way to
I agree.
learn how to.
Yeah, you build up a CV effectively through that way. It's often a way to hire. Yeah.
I love it. Well, we're a little past time, but I think it's okay because we had such good things to talk about. This has been the Pulumi Up Industry Panel on Infrastructure as Code, and I would like to thank all of our panelists today for their brilliant insights. And to everyone else, thanks for joining us, and enjoy the rest of the conference.